next two speakers will give an interesting update on the effect of adding water metering to existing gas and electrical metering. And this will be given by Machiel, Joosse, who's an engineer and will give the more technical part, and Gerrit, who will look after the business side. So this is an addition of water and the advantages of adding water to an already existing gas and electricity smart meter deployment.
What's wrong? I don't know.
Good afternoon. My name is Gerrit Rentier. I've been with Delta for 10.5 years at the management level. 6 years of which I have been spending in smart metering, and more to the point this afternoon in smart water metering. We have the honor to present to you a great concept where we use the smart water meter to actually save energy. And I'll be presenting with my colleague and friend, Machiel Joosse.
Thank you very much. I'm pleased to see so much people, and hopefully you are after the session instead of listener and ambassador. But before we start the presentation. Before we start the presentation, I want to share an anecdote with you. At the end of January, we made at home our water meter smart. And after the maintenance engineer was gone away, my daughter from 7, Mathea, she said, "Hey, Daddy, is that the energy saving meter?" I was a little bit confused. But I thought, yes, really, you're right. And this is exactly the message which we want to share with you. Because did you know that more than 60% of domestic water usage will be heated? It means that when you combine gas and water, you see what you spend on water and gas, and electricity and water seems to be the white goods and so on. The 60%, so my personal situation, parents and 3 children, the eldest is 7, we spend 30% of our gas bill to heating water and 35 to 40% for heating water with electricity. Here you have the breakdown domestic drinking water usage, and you can see how much you spend to showering, dishwashing, and so on. And this is more than 60% of your domestic drink water usage. So the agenda for this afternoon is first a little introduction, then smart metering in the Netherlands, then multi-utility, the effect of multi-utility on the business case. We will wrap up with technical overview, added value, and lessons learned, and next steps.
So Delta is not a regular company in the Netherlands. We are a multi-utility company. We are locally owned by the local governments, and this places in a bit of a separate position in the Netherlands, more like the German Stadtwerke. And we do maintenance for all kinds of infrastructure, for electricity, for gas, for water, and for cable, for television. On a national scale, we also offer metering and utility services. But our main strategy has always been to add value to our stakeholders through synergy. So as a municipal multi-utility, it's quite natural for us to look at smart metering and then think of electricity, gas and water all at once. So this has been a focus in our company for the past 6.5 years. And continuously we are looking for innovation and cost efficiency through multi-utility synergies. Well, smart metering in the Netherlands is more or less well known for people who regularly visit those conferences. We do have a government mandate rollout for electricity and gas, and it's well on its way. It's nearly two years now. But there's no government mandate for the rollout of smart water meters, neither for smart heat meters. But already in 2007 and 2008, when regulation was done and the architecture was done, they specifically made room for slave meters for water or heat or perhaps solar panels. So it's allowed, and it's actually encouraged up to 4 slave meters. And for us as a multi-utility company, it's very natural to look into the possibilities because it's in our strategy. We don't do much in city heating like the German Stadtwerke do, but whatever we will talk to you this session, it also applies to heat.
Okay, here we have the typical Dutch smart metering architecture. We name it in ports, so the P0 port is the local maintenance port, and the P1 port, that is the read-only interface to the customer. It's a conventional telephone plug, and later on in the video we will show how easily it is for the end customer to plug in a device, a tablet or whatever, to get the data from the meter. The P2 port, that can be a wired ambus connection between gas meter, water meter, heat meter to the electricity meter, but it can also be a wireless solution. The P3 port is the port to the central system, and the P4 port, we call that the market interface, and that's for energy companies, suppliers, and the dash line. You can piggyback on that system with the water companies.
So basically the value proposition that we follow was, I wanted to tell you how we got to the idea that we are presenting today. That for the customers, the benefits of smart meter rollouts are usually energy efficiency targets. So we got to thinking about that, and we also thought about a fact from a report by Vasa ITT done for ESMIG, presented here 2 years ago, that in-home displays and direct feedback are twice as effective in saving energy and money to customers. So as a municipal, thinking about our customers, about value, we thought of the idea of let's try to integrate this with the smart water meter concept. So what we basically do is we think that behavioral change with customers comes about by giving them information on which they can act, and not by home energy reports once every 2 months, but actual real-time feedback. So that's basically what we've done.
Okay, when you have the data available, you can distinguish your volumes for gas attributed to heating, to see bath and showers if peaks correlated, and you can do the same thing with electricity and water. So consumers can act their own conclusions, can draw their own conclusions based on the near real-time information, and they also can act. In the video, we want to show you how it works in life.
So there's a bit of a bonus value also, because when you make the system as we just told you for an in-home display or an energy management system, the back-end system could in principle always also give you the usage data on hourly basis or 50-minute basis in a back-end system, and then you could do all kinds of data mining, or big data as it's called today, and then you can give people insight if their dishwashers are less efficient than that of the neighbors, or if they spend more on the bathroom, on showers and on baths than other people in a similar family situation. So we didn't do that in the proof of concept, but we're pretty sure that it would be easily extended to this approach and that it's kind of a bonus value of the concept. Also, there's a nice effect on the overall business case because we've heard a lot of talks today about people rolling out gas or water, but if you do it all in one go, you only have one truck roll. So you save money in the rollout, and there's a lot of synergy, of course. Point is that in a lot of situations there's no stakeholder alignment to do so, but you can save a lot of money that way. Also, during operation, if you have one connection from the homes to the back-end system, if you can do this with one connection instead of 3, you save a lot of money on maintenance and operations. So this is on the cost side of the business case. But what we want to show today is that there's also benefits for the customer. So also on the benefit side, there's a lot of possible value add.
So, the technical overview of the proof of concept. So, on the existing electricity meter, with the P1 port, we have in our pilot or proof of concept, we had the device of fifth play, the energy management system, who collects the data from the P1 port locally. On the existing gas meter, we can also piggyback a water meter solution. And we used the wireless solution from Itron, which we can put on the Cybele, and it communicates to the dongle, which is wired connected to the P2 port. And we had also a second option for a fully integrated solution from Elster. This is a meter also with wireless M-bus, but it's all in the meter. And this is our next step with the DSMR4 meter. We have chosen as Delta Network Group for fully wireless P2 communication. So it means that the gas meter, water meter, heat meter can send the data wireless to the electricity meter. So the dongle is not anymore outside, but it is inside of the electricity meter. Now we want to show you a little demonstration video where you can see the installation, again the architecture, and also consumer feedback. On the existing meter, you need a Cybele, seal and a screw. Put a seal on it. And the next step is that you program the index value from the meter to the Cybele. P0, P1, P2, wireless, P3, and the market interface. And now we zoom in into the P1 port. So the user is in control. Can be easily done. What do you see? Now you see the telegram of the P1 port. And it has the electricity, gas and water meter values. Electricity will be updated each 10 seconds, gas meter hourly. Here you can see the heating of the boiler. We take a shower, and after in the evening dishwashing manually. our solar panels on the roof, the dishwasher, and Mattea has her birthday with her girlfriend, so we had to heat up 5 pizzas and they were really delicious.
So, the status of the project so far is that we got this idea last year at the conference, actually on the exhibition floor with a lot of colleagues and business partners. By December we had corporate level agree that it was a nice concept and that we got a budget to buy the necessary equipment, and together with the business partners we realized the concept. We more or less solved all problems with some colleagues and persons from other companies by March, and we rolled it out early last summer. And it was actually quite surprising that a lot of puzzles were solved very easily, because once you got the standards in place, then the architecture takes care of the rest. So this is the danger, of course, is when you roll it out on the colleagues, is that they know your room number, your phone number. So we got a lot of feedback for every little detail that we didn't fix. All this stuff is now in place. We learned a lot about the concept. Also, one of the things that sets this concept off to energy management systems in the marketplace, a lot of the time energy management systems that you can buy in the smart home paradigm, they use photoelectric cells that you put on the gas meter and the water meter. And there's not much wrong with that, except that it's not encrypted and you can't use it for billing, because it's not, by regulation, you are not supposed to do that. The value add of our solution is that you can also use it for billing. And it's encrypted, so it's all privacy and secure proof. Another value add is this, so that you don't have to do any meter reading in the area whatsoever. Your meter reads will, of course, be cheaper, so you can get all kinds of innovative billing modules. Small companies could be built on a weekly or a monthly basis for hardly any charge at all. And you give room for innovative solutions, something with benchmarking and big data could be done. You can, this concept gives a handle to customers to save money and get more perspective on what they are using in the home. And you also get more on a societal level the benefit that you can do something about sustainability by just saving energy. The lessons learned from this little proof of concept was that because in the Dutch architecture gas is already in place, it's very easy to copy a lot of stuff that you already have in place for gas to water. And to people who have city heat, you can probably do exactly the same. I mean, smart meters for heat are originally all had AMBAs, so you can easily plug it into your architecture and have all the benefits that we discussed. The same story goes for the ICT, for the backend systems. A lot of the stuff that you had in place for gas already also works for water. And we had a little rollout tool that Machiel more or less invented for Delta and presented last year here. Also got an award in the UK for it. Everything was in place for gas, and we just replicated it for water, so it was very easy. The only fundamental issue is that the Dutch DSOs own all electricity and gas meters for consumers, but of course they don't own the water meters, so the only trick is in ICT architecture. So this concludes more or less our presentation. We are now at the point where we do, so what do we do next? Well, a little project already in place is that we are in a Delta company, we're trying to increase the refresh rate between the slave meter and the master. And actually you could already have seen it on the exhibition floor, because the Belgian company Xemex already fixed it so that it works. We have the gas and water meter data every 5 minutes at the electricity meter, so that where you now have hourly readings, you can also do it every 5 minutes, which makes it really competitive in the smart home market. So we will be looking into that and see if we can take this further. And also this December we will evaluate the customer appreciation and see if what benefits customers experienced and take this in the business case. So we will have to address the questions concerning architecture, and what we have learned from the proof of concept about cost and benefit, we will have to take that into account in the business case, and we will present this to our stakeholders. So the bigger picture behind the whole of this is, as we think, that if you have to approach water, energy and nature as a society with respect, as a municipal we think about it a lot, and you should take them into account in one big picture. Thank you.
Any questions?
I would just ask what you said was really challenging, the whole kind of IT infrastructure and asset management. Yeah, one utility owns all the assets, the other one doesn't. So what did you do?
Well, basically, with help of DSO Alliander, we fixed it with a workaround, for which we are very grateful. They just copied the necessary data for the water meters to do the commissioning. But this is just for a pilot phase. If you do this on a major scale, then you have to make perhaps service level agreements and have to do some architecture stuff and proper interfaces. We just, because the numbers were very small, we did it all manually.
Okay, but you still can piggyback on the already existing infrastructure. This is the message.
Because the data structure for the meters is more or less the same for the water meter. You have the same question to commission a gas meter is the same question basically as to commission a water meter or a heat meter.
Any other questions? Last chance. I have one question about how to communicate the information to the end customer, which means an in-house display, a web page. Have you done anything in your initial case study to look after how to communicate the lining up of your water with your gas to say this is happening in that 5 minutes? Because if you have a 10-minute shower, it happens in the middle of your sampling period, you end up losing some of the data or some of that type of information. Have you thought about how to present that type of information, how to try and extract as much value as possible from the data you've already collected?
Yes, in the Dutch situation, the DSO is owner of the electricity and gas meter, and he has to provide the hardware and all the stuff which can be connected by the telephone plug into the electricity meter. That's on the market from suppliers. That's the law in the Netherlands in the Dutch situation, and within a few years, you can buy all kind of devices which you can plug in that standardized port.
I understand the hardware pieces. The question is, how do you get value to reduction of energy from your end customer? Because you have to present it in a certain format, and that is always a very difficult thing to do. Yeah. How to present and effectively obtain savings through presenting bar graphs becomes difficult.
Yes, this was also only a proof of concept, so we kept it very simple. We just had 3 graphs, and the user had to do his own thinking. And from personal experience, from our earliest pilots in 2007, I know that with a bit of intelligence, you can guess what's going on in your home and take decisions. But what we're looking for in the future will be something a lot more nice, where you have graphics which tell the customer in one view what's going on, but we have to develop that.
Thank you very much. Any last questions? Thank you. You're still on time, so that's good. The next speaker will give us a 360-degree view of the world. He is, I apologise for the pronunciation, ahead of time, Julien Machiel. And he's a partner with Inno360, works in France, and not only, and has a